Hello, calculus fans! In one variable calculus, we define something known as work. This is a physics concept. The work done by a force in moving an object through a distance d is defined to be force times distance. Force is measured in newtons, distance is measured in meters, work is measured in joules. Those are the metric units. Now this formula only works when the object is moving in the same direction as the force. Now, we're going to suppose that we have a constant force pointing in some other direction than the motion of the object, as in this picture. So here, the object is moving along a vector from P to Q, but the force is directed in some other direction. Now this happens all the time. Imagine if you're pulling a wagon with a handle that's directed away from the ground. The wagon is moving horizontally, but your force may be directed away from the ground. So here in this picture we have the force is F and the displacement vector is PQ. So we suppose that the force is moving the object from point P to point Q. So our displacement vector is PQ, which we'll call D. So at this point we have two vectors, the force F and the displacement D. We're going to define the work done by the force to be the magnitude of the force in the direction of the motion. That magnitude, we can see from the picture, looks like this. The magnitude of PS is equal to the magnitude of F times cosine theta. Therefore, we can say that the work done by the force is defined to be this. So the work is the magnitude of D times the magnitude of the applied force in the direction of motion, which is magnitude F cosine theta. So we end up with magnitude of D, magnitude of F, cosine theta. Now, work is a scalar. It has no direction. Now its value will depend on the angle theta between the force and the displacement vectors. So what we're going to do now is we're going to define an operation on vectors that's called the dot product. We're going to use this in all kinds of contexts. The vectors that we're dealing with don't have to be forces or displacements. There are other ways that we can use the dot product. It will come up in a wide variety of situations. So we're going to define the dot product of two non-zero vectors A and B. And it's the number A dot B, and the formula to compute it is magnitude of A, magnitude of B, cosine theta. Theta is the angle between A and B. Now we're always going to make theta to be the smaller angle between A and B when we draw them with the same initial point. So that means theta is always between 0 and pi. If it happens that either of the vectors that we start with, A or B, happens to be the 0 vector, then we define A dot B to be equal to 0. Now we call this a dot product because of the dot that we use in the notation. Just this dot right here. Now the result that we get from a dot product is a scalar. It's not a vector. And for this reason, you will sometimes see the dot product called a scalar product. Okay, that's all for now.